Let's start our exploration of Hive with a little story of Fred and George, who both work for a large e commerce firm, albeit in different departments. Fred works in revenue analytics, while George works on the supply chain side. Fred works in analytics, which means that his bosses and managers expect him to have answers to questions, difficult questions about the company's business. He starts his day by sending off an email with a summary of the day's revenue. Fred's email is the high point of the day or the low point of the day for its recipients. Once he's done sending off that email, he starts doing analyses of last month's sales or last year's sales. This takes up maybe an hour, and then some category manager comes to him and virtually begs him to investigate why there was this anomalous drop in sales in that category last month. Being able to pull the numbers and make sense of them gives Fred some power with the category managers, but it also makes him a favorite target of stupid executives. And by 11 am, one of these stupid executives has asked Fred to pull revenue data for the last 3 years and carry out some meaningless analysis. This takes quite a while because there's a lot of data to be pulled. So it takes quite a while because the data request or the question asked by the executive was basically meaningless. But of course, Fred can't say that to that executive's face. So he tinkers around with the data and tries to do the best that he can, analyzing the numbers even as he's running a database pull. He's done with all of this by around 3 o'clock. And then from 3 to 5, it's time for him to prepare a presentation. Presentations like these for the weekly revenue meeting are the high point or the low point for category managers' weeks. Management picks apart the numbers, people get fired, some people get promoted. Lots of questions are asked. What kind of effect did this week's promotion have? There's been a lot of complaints on Twitter recently. Has this had an impact on sales? Is there the need to run a new set of TV commercials? Questions like these are posed and answered by top executives clustered around Fred's deck. It makes him feel good sometimes. Fred's role is actually quite strategic because he has the answers to important questions posed by important people in the company. Of course, every now and then some of those important people don't know what they're talking about and they ask for answers to meaningless questions. But that's fine too. That's a part of what makes Fred feel superior, and that's what helps Fred earn the big bucks, given his background. In contrast to the somewhat strategic nature of Fred's role, George, who works on order management, has a really operational job. Every morning he logs into the order management portal and checks for the status of all orders that have been assigned to his queue. Then he has to rather painstakingly go through and find all pending deliveries or identify deliveries where there is a risk of delay. This is backbreaking and thankless work. He then gets an update from the supply chain team on each one of those at-risk deliveries. He then has to call and follow up with the delivery person to know whether that risk is high, medium or low. Based on these status updates, by around 11, George has assessed the risk of delay in these queries. And he then spends the rest of the day from 11 am to 5 pm calling up customers and carrying out the unpleasant duty of informing them that their orders are likely to be delayed. A whole bunch of these customers are rude and they yell at George and they cancel their orders. Some of them ask for an additional discount and they threaten to get onto Twitter and say bad things about the company if they aren't given one. And then lastly, there are some reasonable folks who come up with a suggestion. Why not reroute their orders to an alternative address? Patiently and painstakingly, George notes down all of these. He's collecting all of them in his notebook. He then makes the appropriate updates in the order management system. And then the company's software kicks in and it takes these updates, which George filed in the order management system, and it instantaneously does a whole bunch of stuff. It reverses a few orders, it contacts some vendors. If the delivery path needs to be reversed, it might also update the customer's credit, so it needs to talk to the accounting system. It also probably needs to have some interface with the delivery routing and the system for field executives who get out and actually deliver stuff. As you can see, George's work is very, very transactional. It's very operational. He's on the phone, it's a backbreaking job, and unfortunately, it's not very appreciated in the company. And that's why George is looking to move into revenue analytics and take Fred's job if possible. At one level, you might think of this as a parable of the power of big data technologies. Folks who use these technologies work in the relatively sexy departments like revenue analytics, and those who don't are consigned to the boonies, to departments like order management. This was meant strictly tongue in cheek, but you can't deny that this is partially true. In any case, that's not actually the main point of this long story. The main point is to contrast the kinds of systems, the kinds of software systems that Fred and George need to work with. Fred almost invariably deals with aggregates of orders. It's very, very rare for Fred to actually care about a single order of any type. In other words, he's analyzing batches of orders. He's looking at large collections, large aggregates, maybe cut by category or time period, maybe monthly or weekly or yearly. George, by contrast, is almost exclusively interested in individual orders, which he has to painstakingly track and follow up on. That's one primary difference between Fred's work and George's work. Fred only reads the order data and draws insights from it. George, on the other hand, actually also has to update the order data. Remember that if an order is at risk, he needs to act. He might even have to cancel the order or change the delivery address. The nature of Fred's work implies that he's okay with long-running jobs. It's not like the world is going to come crashing down if he takes maybe an extra hour to prepare his slides, despite what the top executives of the company might believe. But that's not the case with order management data, which really needs to be real-time updatable. Changes happen all the time, and these need to reflect instantaneously in all system components. Imagine, for instance, if there were a lag of several hours between an order being cancelled and the accounting system or the consumer's credit being updated. The company would have a large fire on its hands to put out and a huge public relations nightmare. George's order management system needs to be really fast, else the lights will go off at this e-commerce company and there won't be any money to pay those salaries for those top executives. In addition, Fred actually needs to be able to connect the dots between different types of data. A key part of his job is looking at aggregates and looking at different data sets in the company at a glance, summarizing them and combining them intelligently. George, on the other hand, has a worm's eye view. And this truly is one of the most attractive aspects of Fred's role, that he gets a bird's eye view while George just needs to see the current set of orders that are in his queue. This bothers George because he isn't learning about the e-commerce business this way, and that's one of the reasons that he aspires to get Fred's job. Fred and George both frequently need to look at order data. Both of them are actually fundamentally looking at the same data store. Both of them need a database that stores this data and maintains the fundamental database properties of atomicity, consistency, isolation, and durability. But the databases that Fred and George really want are very different. They need to satisfy very different needs. Fred's database works with batches, while George works with individual orders. This means that Fred's database needs to be optimized to handle large quantities of data at one go. George's data, on the other hand, needs to be able to quickly zoom in and zero in on just one order, the lowest possible level of granularity. Fred is focused on reading the data. George needs to both read and write the data. Once again, this difference, this divergence has implications for the design of the systems that Fred and George are going to use. I think you may be beginning to get the drift now. Fred's database needs to specialize in complexity. George's database needs to specialize in making transactions fast. Fred looks at multiple data sources, and therefore his data source needs to be huge. It needs to combine data from different data sources and be a really large scale one. George's data source is narrow and can potentially be much smaller and more compact. Analytical processing or transaction processing. That fundamentally is the difference in the two paradigms. Fred is interested in analytical processing, where he has complex transactions and he wants a bird's eye view. George is more interested in transaction processing. He wants to be able to get a really accurate worm's eye view. In the past, when the amount of data that organizations created was relatively finite, systems could manage both of these at once. So you could have one database management system that was all things to all people. But that's not the case anymore, as the amount of data that's collected by an organization, like a large e-commerce seller, explodes. The requirements for these two types of databases have diverged significantly. Transaction processing systems are still like the old school traditional database management systems. Traditional databases continue to be used in a whole bunch of places. MySQL is all that you really need. Analytical processing systems, however, have become hot, and these are also where the margins are for the software companies. Data warehousing is an entire business. Providing business intelligence or data warehousing technologies is big business for a host of providers. Data warehouses combine all of the characteristics that we just listed. Data warehouse technologies have proliferated. Some of the most popular ones these days are Vertica, Teradata, Oracle's BI suite, and a suite of IBM's tools. You should note, by the way, that Oracle and IBM have separate BI suites and transaction processing or database suites. That's because these companies have sophisticated bits of software which specialize in the application that they are used for. Vertica, Teradata, Oracle's BI suite, IBM's tools, these are proprietary and paid software. These are closed source. But there is also a formidable open source contender in the data warehousing software space, and that is Hive. And that's what this class is all about. Hive is an open source data warehouse. That's what makes Hive special, and that's why this class is devoted to Hive. Hive was developed by Apache and is part of a large ecosystem of open source distributed computing applications which more or less usually depend on Hadoop. Apache's distributed computing system is explicitly built around Hadoop, and Hive is also. The relationship between Hive and Hadoop is worth understanding, and so we're going to talk about that in a little more detail in the next video.